So you've got a little bit of a background of how the Java syntax works right now. Hopefully, hopefully that's gotten you to a point where you're like, okay, I can get this. It's very, very similar to languages that you've used before. So I don't think you're going to have very much trouble getting going. It's not your first programming language, it's your third. So that's going to mean that there's a lot fewer stumbling blocks along the way. That being said, be very careful about that fact that we said string equals. If you're going to compare two strings, you have to use that equals method. That always trips people up, coming from both JavaScript and C#, where that wasn't the case. That kind of feels like a new thing, and so it's just kind of something you have to pay attention to is when you're doing equality, you're testing for equality. Cool. The good news is, large in part, the compiler or the IDE will warn you. If you're using the equal signs with two strings, it will more than likely tell you, hey, this is something you probably shouldn't be doing. And so if you're just paying attention to the IDE and the suggestions there, it will suggest that you should change it to not equals. So the IDE will help you in that process. Two documents in here, now that we're getting into the textbook. There is, briefly, I threw up here the introduction. Feel free to read that. That'll give you a little bit of background of where this textbook and what the course is. But I'm going to go ahead and jump right into lesson 1.0 today. So as this is broken down, the textbook's broken down, first of all, into 4 units. Each of those units have several lessons. Within those lessons, there's several parts. Right, so there's like a lesson 1, which is what we're going to be covering this week and into next week. And we'll be starting through lesson 1.0 today, and then we'll be finishing up with lesson 1.4 on next Tuesday. So that's kind of where we land. We're going to try and hit one of these once per day. They're all pretty short. The first lesson's pretty short, so we should be able to get through these at that rate. Each of them, except for 1.0, 1.0 does not come with a lab. All the other ones do come with a lab. Yeah, I think Perusal is having some troubles on me. So if this doesn't come up, I will go over to pull it from another source. There it goes. Okay. So let's talk about 1.0, which is really your introduction to Android. As I said, there's no lab with this one. The first lab you get will be with 1.1, which we'll cover tomorrow. So you'll have a lab assignment tomorrow. We don't have a lab assignment for today. All right, so talking about what Android is. Android, you more than likely, I think that most of you have one in your pocket, and for the most part, you have received one. You've received a tablet from me with a chance to kind of play around with that and use that this semester. So this is what we're dealing with, right? We're dealing with these mobile devices, largely smartphones. Largely is the category they fit in, but there also are tablets as well, right? Tablet market is much smaller, and there's a lot going on there. In fact, there was an announcement, I think a year or two ago, that Google decided to stop making tablets, which is kind of weird. But they have stopped doing that. Samsung has continued making tablets, and it seems to be going that route, but Google decided it wasn't really a good market. Now, I don't understand. I don't know what all the reasoning behind that was, but that is that. So where the tablets go, I don't know. I know there's a lot of companies. I know a lot of companies are using them in schools, and a lot of hospitals are interested in using tablets at there. So where that market goes, I don't know. It just seems that Google's taking its foot out of producing tablets and focusing on producing phones. So those are the two main things that we're targeting, right? We're targeting your phones, we're targeting your tablets. There's also Android devices out there, namely Android that are categorized as Android Wear. You might have seen smartwatches out there, right? So those smartwatches that run Android Wear are also Android devices. They're not the thing that we're going to talk about how to work with this semester, but you can apply some of the skills that you learn here to also deploy code to smartwatches. Similar thing, there's also been historically an Android TV. So there are some TVs that run and are powered by Android. You can also build apps for them using Android Studio. So there's a lot more out there. There's also an Android Auto. There are some cars that actually have Android in their dashboard, and you can use Android Studio to build apps for them as well. So just recognize that the market, right, is not just mobile devices. What we're going to be talking about entirely here is mobile devices. We're going to be talking entirely about smartphones and tablets and not any other kinds of devices because that's outside of our scope. But a lot of this stuff applies to those devices as well. Okay? For the most part, they're just a different form factor, but there are additional rules as far as getting onto those app stores because the Android Auto app store is actually a separate app store. Things like that. So there are things you have to do. So we talk about why develop apps. For most businesses, I hear most small businesses around the area, mostly it's just a nice thing. And historically, it's just been, I want to get out to more people. I want my business to be in front of more eyes, or I want, hey, this app thing is kind of cool. Hey, we got an app now. So sometimes that's just a selling point from them, and a lot of times it does come down for the business case. A lot of it does come down to push notifications, right? A lot of the business case for a lot of companies comes down to, oh, I have an app, so now I can send them notifications when they're not on my app to bring them back, because traditionally you haven't been able to do that with a website or a web application. Right, PWA is kind of a new foray. Like, oh, you can do push notifications. Well, maybe I don't need an app, right? If I can get that, so that's a really big part of the business case is those push notifications and other such features. So there's a lot of different popular apps out there. You've got music players, you've got Pokemon Go and other games, including AR and VR games now. You've got people sending messages, text messages back and forth, or Snapchat, etc. All of those are really historically been programmed in Java and Android, right? If you're running it on an Android phone, there's a very good chance that it was written in Java or Kotlin, which is the newer option. So just thinking in terms of the interface, one thing to keep in mind is that all of these devices are touchscreen enabled, and that's the primary input mode. Okay, most people are going to be interacting with your app entirely through touch, which is a little bit different if you're used to developing for desktop. You're used to developing for a mouse and keyboard. And that does come with some additional considerations and some additional design choices and practices and procedures that you have to follow to fit in with that, right? So that means that large in part, there are very few, if any, physical devices on most Android phones. In fact, most Android phones, the only physical buttons they have today are a power button and a volume rocker. That's it. Pretty much everything else is software. Even your back button and your home button, those three buttons that appear at the bottom of the screen, those have typically become software buttons. Those used to be hardware buttons, but those have become software buttons. With that in mind, a big consideration that you have to keep in your head is that most people will be using a soft keyboard, a software-powered keyboard, anytime they interact with your application. If they need to type out some text, they'll be using that software keyboard. That software keyboard doesn't behave like a hardware keyboard. That's a common misconception, is that a software keyboard is just, hey, it's a keyboard on my screen. The differences are much more significant. So for one, there's actually still less space. It's not a full keyboard, right? There's a limited amount of space, so you actually only have some of the keys. You don't have an additional numpad. You don't necessarily have arrow keys and other things like that. So it's a limited keyboard, but oftentimes those keys do more than one thing. And not in the way that you're used to in terms of like a desktop keyboard. You have Control, Shift, Alt, or Option, and Command if you're on Mac. The way that you typically switch between the different functions is you do a long press on the key, that pops up you some options, and then you can pick from that list of options. So it's a little bit of a different interface, and you do have to design for that interface, right? So in addition to just the differences there, and another thing that happens, I don't know if you've used it, but a lot of Android devices support the whole squiggly drawing. You can just kind of swipe your hand around, touch the finger, touch the characters, and not lift your finger up and get a word out that way. So that's an option there too. So there's that. The other side of things is that keyboard occupies a significant amount of real estate, right? We don't have that problem when you're designing for desktop. When you're designing for desktop, your keyboard doesn't count towards what's on your screen because it's not on your screen, right? But when we're building for mobile, that keyboard is going to be on screen. It's going to take up a portion of the screen. On smaller devices, it may be anywhere from a third to a half of the entire screen, right? And so you have to plan for that. You have to plan for, oh, I'm going to lose half of my screen to the keyboard, right? So all the space that I have left is that tiny little space that's above the keyboard, right? I've got that half of the screen that's above the keyboard. That's all I have to work with. Now on tablets, like the 7-inch tablets that you'll be testing with, there is a little bit more space. In those cases, the keyboard, at least in portrait, usually only takes about a third of the space. But if you turn it into landscape, if you have that tablet in landscape, you will find that the keyboard takes up half of the screen. It's a good size screen, but it takes half the screen because it actually becomes bigger when you turn it sideways. Okay, so that's one of the reasons why oftentimes I may use tablets like that in portrait mode over landscape because of the way the keyboard scales and things like that. Right, so the soft keyboard is a very, very important design consideration as you're building applications. Okay, cool. Also means little things like, where do you usually put your submit button when you're building a web application? Where do you usually put that submit button? Probably down at the bottom of your form, right? Guess what's covering your submit button? The keyboard, right? So if you put a submit button all the way down here, it's going to be a problem potentially for your mobile users, right? So actually it's preferable from a mobile perspective to put your submit button where? Up top. It's actually better to have the submit button up top because then you can always get to it and the keyboard will never cover it, okay? So there are design considerations like that that might seem weird. Again, if you're coming from the desktop world, throw away the conventions that you know about designing GUIs because a lot of those conventions don't necessarily carry over, right? So a few things to keep in mind. That generally means it's usually preferable to have submit buttons or other buttons towards the top of the screen instead of the bottom. Recognize that you're going to have, half of your screen potentially reserved for the keyboard. Also in that mind, typically speaking, you can't have anything horizontal. On a smaller smartphone especially, nothing will fit horizontal as long as you're in portrait mode. Now, on landscape, it's a little bit of a different story. If you're in landscape, well, then you have more space horizontally and less space vertically. You essentially have to lay things out horizontal. right? So in landscape mode, things really have to be laid out horizontally as much as you can, versus in portrait mode, you need to lay it out in as vertically as you can. Cool. So that oftentimes means your design is a little bit different between portrait and landscape. Okay. Sometimes that means going into Balsamic or whatever tool you're using and making two completely different designs. And we'll even look at how to make two completely different designs within Android Studio, right? So here's how I want it laid out in portrait. Here's how I want it laid out in landscape. And those are things you have to constantly be keeping attention. So looking a little bit here, they have kind of exploded view to just talk about the general UI. You'll notice at the bottom of the phones, there's 3 buttons. So the leftmost button, which looks like a little triangle, that's always going to be your back button, pretty much. The other side, on the other side, the square, typically will call up whatever programs you have running. And then the circle in the middle typically takes you to your home screen. So that's what those buttons are there for. The triangle actually on modern phones has a dual function. Does anybody know what the other function of the triangle is? Has anybody ever seen the triangle appear like this instead of to the left? Why did that happen? Sometimes you'll see the key, and you'll see the arrow. It's actually there. If we look on that page before, I think I saw it on your screen. There it is. Do you see that little arrow there that's upside down? It's kind of pointing down. So when the keyboard's up, actually the back button changes to a high keyboard button. So that down arrow actually represents, hey, I want the keyboard to go away. That's another side of the fact that these are hardware buttons, right? So, or software buttons. Because they're software buttons, they don't always have the same functionality or the same icon, right? On some devices as well, sometimes the bottom right icon will be a square, and sometimes it will be a pair of 3 lines instead of 3 lines. Those things happen as well. Another function that happens with the middle button, oftentimes if you hold it long enough, you'll get into Google and Google Voice Assistant and such. So those buttons are pretty important to have some sort of understanding with. The current kind of design scheme with Android since 5.0 goes by something called material design. Material design is kind of the convention for when you're building Android apps. It should follow material design principles, okay, which we'll talk about towards the end of this course, and as far as what does that mean and how does that fit in. But a lot of it has to basically come down to physicality. Is it should feel like the objects in your app are real things that have 3-dimensional aspects and shadows and things like that. So that's kind of where that fits in, and you'll see the popping out there of those different pieces there, animations, etc. So in terms of developing apps, we'll be developing them using the SDK. We've already downloaded it, and we'll be using, and it's kind of built in and baked in now with Android Studio. It used to be that you could download the SDK as a separate thing and then use it with whatever IDE you wanted. That's now really integrated part of Android Studio. So we'll be using that. There's 2 kind of primary languages that we'll be writing in. We'll be writing in Java is for our code, but we'll also be using a lot of XML for resource files as well. So definitely familiarize yourself with XML as we go through as well. Ask questions. XML is very similar in a lot of ways to HTML, but it does have some nuances, and so ask anytime that things seem kind of odd. Yeah, so we'll be using Android Studio in there. So to kind of talk about the architecture of Android, we have down at the bottom at the bottommost layer of your Android phone is actually what we call a Linux kernel. It's the same Linux kernel that you would find if you're installing and using a Linux operating system on desktop. It's the same Linux kernel. So at the very root, Android is Linux. It is a Linux distribution in that sense of the word. Okay. So you do have to recognize if you get far enough down that you will be encountering Linux shell commands and things like that if you get far enough down into the weeds. Above that, there's what we call the hardware abstraction layer, which just abstracts the hardware that's beneath. So you have a software interface that's standardized. You can kind of think of that as your drivers in Windows. That's where your drivers live. Above that, we have the Android runtime, which is where we kind of come in, as we start to build up on top of that, that's where we run inside of. There's also a bunch of native C and C++ libraries for doing things like 2D graphics and 3D graphics and sound and other things you may want to do down at that low level. Okay, so it is possible to interface with those things, and the Java API does. Okay, so from there on, we've got the Java API framework. This is our best friend. Like this is what you'll find in the documentation. When you're looking at the Java API docs, what you're looking at is this Java API here, this Java API framework. So that's where we will spend 90% of our time, right? We won't actually dip down into any of the stuff down below here. You can, if you're building games, then I absolutely recommend to. But if you're not doing anything games or VR or AR, you're really safe staying up here. For most business applications, they're safe staying above that green layer. Yes?
Probably a slightly off topic question, but is it like a big stretch to go from like doing web development to like doing like firmware and driving like software? Is that like a
Absolutely.
big gap?
It is a big gap. Yeah, it is a big gap. In some sense, yes, it's programming. Yes, there's loops. Yes, there's if statements. Yes, there's variables. Yes, you've got integers and other data types, but it is otherwise very different, right? So when you're dealing with drivers, and when you're at that level, you're actually really close to the electronic side of it. So actually one of your best friends for testing are things like oscilloscopes and multimeters, right? If you're down at that driver level, you want to have your multimeter and other electronics gear handy because that's part of how you will do your testing, right? So that's the part of it, right? Part of it is understanding that actually you have to bring in some electronics equipment at that level versus like if you were trying to go into the C and C++ libraries, well, you just need to understand C and C++ and some graphics rendering in OpenGL. You don't necessarily need to understand the electronics, if that makes sense. Versus down at this layer, you're talking about electronics. So it really, there's a lot in terms of specialization and where you want to go into. And, one of the things to do there in terms of how you want to specialize, I would recommend finding a company that you want to work with, look at who they're looking to hire, look at what skills they're asking for, and then go from there, right? Because depending on what industry you're trying to get into and what kind of position you're looking at, the skill layout that you need will be very different, right? There aren't a lot of people doing stuff with the how. Just hands down saying there aren't a lot of people touching that layer. And there's not a whole lot of people touching the C and C++ libraries either. That's not a huge group of people. So large in part, most people live up here in the user app space or the system app space. So system apps are apps that are pre-installed by the manufacturer. So for instance, if you get a tablet from Samsung, well then Samsung's pre-installed their apps and they're running as system applications. They have a higher level of permissions and things that they can do, and they're also can't be uninstalled. System apps cannot be uninstalled. You can disable them in some cases and prevent them from getting updates, but they cannot be installed versus uninstalled versus user apps can be uninstalled. They're the place we're going to focus, right? So the corner where we're going to focus this semester is this corner right here, is user applications, working with the Java API framework. That's where we sit in the whole mishmash of things. Cool? There are a bunch of different distributions. So there's not just like one version of Android. In fact, every manufacturer kind of makes their own version. So if you get a version, a smartphone from, say, Samsung versus Sony versus LG versus Google, you're going to have a slightly different OS and a slightly different UI to do a lot of the things. They standardize around a lot of things, but they standardize around a lot of different UI bits, but they're not all the same. They mentioned there's a few different distribution options. As of speaking today, there really are only two ways to distribute your apps, your Android apps. You either distribute them through Google Play Store, or you distribute them through the Amazon Fire Store. It's really largely the only two options. It is possible, there are other people that have tried to spin up other app stores, and you can install other app stores on a phone, but large in part, they are not as populated. There's not a lot of people there on those other app stores that they have spun up. So if you really actually want to get it out to most people, you typically have to get it onto one of those two stores. Cool. It is possible to send APKs and things like that, where people don't necessarily have to get it from the store, but very few people do that. Very few people do that. Android versions, we talked about that a little bit. The big part that affects our code is the API level. This is a little bit dated because, as you can see, the latest one on their chart is 8.0 and API 26. Whereas we're all the way up on API 32 now. So, important things to note, and this is definitely something to take note of. What are some of the challenges of building Android apps and in Android app development? Okay, a lot of this actually does carry over, regardless of what technology you're using. Whether you're building them in Android, whether you're building them in Java, whether you're building them in Kotlin, whether you're building them with React Native, or you're building things with PWAs, these are all things you need to keep in mind as far as things that your users are kind of paying attention to. So you got to first of all make sure you're building, as they say, building for a multi-screen world, right? So building for the fact that your users may have more than one screen, and those screens will be different form factors, right? So not every phone has the same dimensions. They may not even be in the same ballpark, okay? So there's a lot of phones that, maybe they're skinny, maybe they're pretty short and wider, or they're tall, right? There's a big range of different screen sizes and resolutions that we have to support, right? So you have to think of, okay, well, how big is the screen physically, but also how many pixels are on it. In fact, there are phones where if you compare the two of them, you'll find, hey, this one, they're both the same size, but this one literally has twice as many pixels, which means that the screen density is twice as high. We do have to account for that. We do have to plan for that. Not just the size of the phone, but also the screen density. Okay, so those are things we have to pay attention to. Users also, a lot of users, if they have two devices, they expect to get their data from device A to device B, right? If they have a phone and a tablet, they expect to use your app on both and be able to access their same account. That's an expectation. right? Or if they have a laptop and a phone, will they expect to be able to use that same app on the laptop and the phone and the data transfers between them? Part of why I mentioned, hey, PWA is such a helpful thing because you're kind of already there in that regard, right? But that's a really important thing, right? That is a really important thing, the data transfer as well as the consideration of form factors. Cool. So recognize that you have a bunch of different devices, a bunch of different formats. Performance is really important. You have to make sure that you get performance right when you're dealing with mobile devices. It's a lot easier than it used to be. Okay, let me stress, it's a lot easier than it used to be. Our devices are a lot more powerful than, say, the iPhone 1, right? Or even the first Android devices that were out there. Clock speeds have gone up significantly. There's a lot of other things that have affected performance, and there's GPUs and neural chips. They're even going in there now for machine learning and things like that. So performance is a lot easier than it used to be, but is really not something you can neglect. Okay, because performance on a mobile device affects a lot more than just what it does on desktop, right? So if we think about performance on desktop, what's the main outcome you get if your program is slow? You're running a desktop and the program seems to be running slow. What are your users gonna how are your users gonna respond? Huh? They might turn it off.
They might jam their fist on the keyboard and punch your screen.
Hopefully not that, but they might use your app less, right? They might choose to use somebody else's app because it's faster, right? They might be sitting around on their screen and waiting, and okay, well that took 30 minutes. It's kind of annoying. Meant I got less work done. But actually, to some extent, desktop users are a little bit more forgiving for slow performance than mobile users are. But there's also other things there, right? So if your app seems to be running decently well, but your CPU is kind of getting hot because it's working a lot, do most desktop users care? Okay, most desktop users, the fan's going up, it's hot, it's annoying, but whatever. I have no control over it. The same thing happens on your phone. Your pants are burning. And you're like, no, can't do that, right? Your thermal limits in terms of working with mobile devices, with Android devices, are much lower than what people are willing to accept with a laptop, right? So that inherently means you have to tune the performance even more, right? You have to tune the performance more than what you would do there. Other thing to consider, if we're talking about a desktop or a laptop, we're spending most of our time plugged in, most of the time plugged into a power outlet, right? That's not true for your smartphone or your tablets. Most of the time they're unplugged, most of the time they're running off a battery. So any juice, any calculations and stuff that you're doing on that CPU is simultaneously draining battery power, right? So the less efficient your app is, the more battery power you're using, the more you're shortening the life of their battery, right? So it's not just affecting, the performance of your app affects more than just how fast your app appears, but also how much battery you drain, right? That's a really important concern. That is a really, really important concern. Is how much battery are you draining? And it may be in some cases worth it for users for your app to run slower in exchange for better battery life. Actually, most users will take that trade. Most users will take the trade of slower performance in exchange for better battery life. So it's not just performance that wins the day, right? Or not just CPU performance that wins the day. It's also battery performance, and it's also, well, if I'm doing a lot of work, Oftentimes that lot of work involves trips to the network, using the cellular towers, using Wi-Fi, right? Wi-Fi consumes a lot of electricity. Your cell tower, that radio communication consumes a lot of electricity as well. Screen brightness consumes a lot of electricity. But the big thing that comes with that network activity is that their network traffic, their 4G, their 3G, that service is not free, right? In fact, for most people, it's still limited. It's still capped, right? Some countries, they're still paying per megabyte, per gigabyte, right? Um, Here we're largely, okay, well, you get capped at 3 gigs, 5 gigs, wherever that number is, but you don't want to be capped at that point, right? So you have to be balanced with how am I using electricity and battery? How am I using the data? How am I using um, the CPU, right? Can I balance all of those performance metrics together? Cool. So it's not a simple where usually in the world of desktop and web development and the things that you're traditionally familiar with, we're just concerned with, well, how long does it take to do something, right? I don't want to wait, right? I don't care about anything else, just make it fast, right? But that's not what we want from mobile. We don't want just make it fast. Make it fast, make it consume the least amount of battery and the least amount of data. And also anticipate what I'm going to do before I do it, so it's there immediately when I ask for it. It's another requirement. In addition to dealing with bad connections, going through tunnels, being on an ocean cruise where you have limited signal, et cetera, et cetera, et cetera. So there's a lot of things you have to do there. Securities and privacy, both of those are a concern today. So we have to think about those as well. When you're working from your home, then you have maybe less things to worry about from a security perspective, because in theory you've got a lock on your door and whatever other security that's already on the house that's protecting the device, and your device is only within range of basically your neighbors. So you're usually a little bit less concerned about security. But once you take a mobile phone out and you're out and about, you're with a bunch of strangers on strange networks using, hey, if you're at the coffee shop, you don't know who else is on that network. If you're at the hotel, you don't know who else is on that network. You don't know who else might be seeing your traffic. So there's a lot of additional security concerns that come in because you're mobile, but also in the sense of, well, what if somebody wanted to track you in those radio signals, right? So there's a lot of other things that have to be considered, right? Is if I say, okay, well, this is an acceptable password for my home, maybe that's not an acceptable password on my mobile phone, because somebody's more likely to get my phone than they are to get my computer, right? I may need a fairly strong password on there, but there's also just questions of ease of access, right? It's worth mentioning, a lot of modern smartphones now have thumbprint sensors, right? For you to log in. I hate to break it to you, the main reason for that is ease of use. It's not really a security feature as much as an ease of use feature. It makes it very easy to get in your phone very fast with just a finger, but it's actually not that secure from a security standpoint. Cool. There are some security problems there. Okay. Also have to make sure that our app is compatible with different versions. That's really important from platform versions. So when we set up the project, we'll have to say, hey, I support the latest version, but I also support back to, say, version 24 or whatever it may be, right? So I have to say I support this range, and I have to do different things based on what version of device the user is doing. So oftentimes that may mean we have to write more than one version of the code, more than one version of a function, to deal with differences that have occurred over the lifetime of Android. right, over the course of those APIs that we're supporting. And then just understanding the general market and user, right? That in of itself is that's a whole nother course, right? Of figuring out what does your market want, what are their needs, how are they operating, and how does the user, what are the constraints that they're within. So from building within, I think we talked about these. So we talked about multi-screen world. We talked about the performance side, and yeah. So that's the kind of the gist of the kind of intro to the world of Android. So there's a lot of considerations that you're going to find in the mobile world that maybe you hadn't thought about when you were just doing web development, when you just had done other things. It's like, oh, okay, I also have to think about that. I also have to think about soft keyword, et cetera, et cetera, et cetera, et cetera. Another thing that comes up, I'll just mention off the side, is that oftentimes the app has to be translated into other languages. So like translating to Spanish, translating to Chinese, translating to Japanese, German, etc. Right? There's some additional complexities that come with that, but that's one of those things that you expect from an Android app. Everybody good? Cool. So that's lesson 1.0. It just gets you introduced into that. So let's go ahead and take a break. And judging by the fact that we are at 2 o'clock, I think we'll have some time to get started on lesson 1.1 today. So go ahead and take a 15-minute break. We'll come back at 2:10, and we'll go on with lesson 1.1.
This Android Developer Fundamentals version 2.
Yep.
Is that the text that you have us by?
Yeah.
Okay.
That's not by, but that's the text that we're using. Should have been free. Did you have to pay for a textbook? Did you pay for a textbook at some point?
We can take a look. What's the name of that website again for buying textbooks? I forgot what the name of it is. I always click links on email.
If you look under, pull up the new tab.
Isn't that ebook, Ranken ebook or something?
Just pull up the new tab. Pull up the new tab. And try it right from the
Web store or something.
eCampus.
eCampus, that's something.
Yeah. There shouldn't have been a list in, unless I checked there wasn't.
So I bought this.
That should not have been on the list. We took that off last year.
So what I did was I went to this. Or AWD. We are 1112, I think.
Yeah.
I think we're section 1.
We originally had added as an optional book, and we've gone back and forth on it, but
yeah, 10112 L1
yeah.
L1. So that's what I did. And then this came up.
That shouldn't have been listed. Okay.
Doesn't matter to me. It's only $20.
It's fine. It's a syntax reference for Java, but we will not be using it.
This is like what, maybe 30 pages?
Yeah.
How much syntax could there possibly be?
Yeah, and it does a good job that covers most of the Java syntax.
Anyway, I
actually,
do have this book
but
now. I picked it up yesterday.
Yeah, I think there's still an item or two that's not in there.
I'll have to ask everyone else, see if they bought it too. I don't know.
Yeah.
I don't remember reading anything about you saying we should look it up, but when I was ordering textbook for my math
Okay.
for my other class, I decided I'll just look for AWD too.
Okay.
And there was something there.
Okay. Yeah, because we had listed that one in previous years, but we had removed that one.
I see.
So, and I thought that last time I checked with the bookstore, it wasn't on there before the semester started, so. Anyway, yeah, it's a perfect book. Yes, it's only $20. So, take it or leave it, but.
Did I buy it in paperback? Okay.
I think it's only offered in paperback.
Sure.
But we took that off the list last year. So we're talking about books.
Interesting.
So that means they're waiting for it to be shipped. Because you haven't received it, right?
This is apparently no, I haven't received it.
Right.
I didn't open the box yet. I just picked it up last night. But
Okay.
it's this one that I have.
You can get a digital version of it as well.
So what should I do? Return it or should I keep it?
It's up to you. From my perspective, we're not going to be using it. That's what I can say from our perspective, is we won't be utilizing that textbook. It's not that one, I don't think. It's that second one. Yeah, that's the second.
Where are the page numbers? Wait, there's 130 pages.
Yeah.
That's a lot of pages.
That's not quite right.
Anyway.
Okay.
Cool. Just wanted to know.
Okay. If you haven't yet, go ahead and start Android Studio because we'll be using Android Studio for the second section. What's happening with the screens up here? And that's plugged in? Or...
No, they're just incomplete.
Let's see. Make sure we get the driver. Oh, that reminds me. I need to grab. Okay. Okay, so working through 1.1, and so 1.1 is going to be our first really diving in point for Android Studio. So we're going to find out how to use Android Studio, how to make our first app, and how to get that onto a device, right? I'm going to show you how to set up both emulators to make sure you can test it and run it on an emulator, as well as run it on the physical device as well. So we're going to do both of those two things today. Okay. So the general process in terms of how we go about developing apps is a multi-step process. There's a few different things we have to do to get to the point where we can have an app that's published and on the Play Store. Okay, so large in part, we can break it down into these steps. So first thing first, create the project, right? So we're going to do that here in a minute. We'll create the project. You have to define layouts. Namely, we have to define layouts for every screen, and those will be created as XML files. So each screen will have a layout file. We'll then write the code, which is written in Java. If you remember back, maybe when you're working with Windows Forms, you had this kind of idea of maybe a code behind, right? You had the designer, the drag and drop designer, where you move things around with Windows Forms. We've kind of got that idea as well. But we also have Java code that we're putting in as the quote-unquote code behind, which is where we'll have all of the actual logic. So what happens when you click on a button? What happens when a user types something in? What happens when yada, yada, yada? So responding to events falls entirely on the code. Next thing in there, you're going to build the code and run it, right? Test it on a virtual device or a real hardware and see if it works. You're going to debug it as we go through there, and then repeat the cycle. Write more code, build and run, write more code, test and debug, etc., etc. You go through that loop, steps 3 through 4 or 3 through 5, until you get to a result you're happy with, and then finally you publish it, right? So that's where we're jumping in. We're going to start that process. So I'm going to start up Android Studio now. There are some screenshots I will mention in this chapter, 1.1. Most of them are outdated, just a heads up. They are similar to the screens that we see, but Android Studio has moved the screens around. They occur in different orders, and they look differently. So be very aware of that as you're moving through the instructions, as things may not be where they used to be. Okay, so in fact, even the new UI that you guys have is different than it was last year. This UI didn't look this way last year when I taught this course. It has changed pretty drastically, enough to me like, what? Where are things? Okay, so in this version of Android Studio, which is I think 2020, we will start here at the home screen. You should see a panel on the left that says projects. So we're going to make sure that we're under that. Okay, we're going to click this button that says new project to start a new project. All right, first thing it's going to ask you here is what kind of activity, what kind of layout do you want to start with? Okay, there are a bunch of different options. There are a bunch of different options for what you can start with. Not only do they come with a layout file, they also come with some code behind them, some more than others. Okay, so there's a lot of choices here. We will absolutely not be using all of them, especially since a number of them do come with maybe more code than we'd like to start with. So the one that we're going to spend most of our time with is actually this one right here, which is the simplest one. It's called the empty activity. Okay, the empty activity, as the name suggests, is the bare minimum. It basically doesn't have anything with it to start with. I have found in my experience that most of the time, this is the best place for me to start. Even knowing some of the other things, I oftentimes will find it easier to start with an empty activity than starting with one of the other things that are pre-built, just because of how much code they bring in, which oftentimes I end up throwing most of it out. So we're going to start with empty activity, and that's where our first several projects will go. The only other one that we'll really do anything with is going to be this basic activity. Basic activity also has some stuff we want to look at later, but we're going to start with empty activity. Okay? So if you start a new project, you're going to be starting it with empty activity for the moment. We have to give a name to this project. I don't know if I can zoom this in at all. So the first field is the name of the project, and maybe we just call this Hello World. Okay, so we're going to call that Hello World. The next question is, and you'll notice I do have a space in there. The next question is the name of the package. Now, it will have pre-filled that in as com.example and the name of the app we just typed in. So it's going to be com.example.helloworld. Well, we need to change that. So the package name that you're going to use, and actually we can set this once and it's going to be the same for the rest of the semester. It's going to be edu.ranken. Okay. So you always start with basically a domain name. Okay. So you're starting with edu.ranken. Which you'll notice that that's backwards from our domain name. Our domain name is Ranken edu. And then we get it more specific. So I want to say, well, which student is this for? So in my case, I would type in Paul Smith. And maybe Paul_Smith as my name. If I remember right, I don't believe that we can put dashes in here because dashes are not valid in a Java identifier. Okay, so you can separate words with underscores. You can't separate them with spaces or dashes. Underscores are your only option. Also, absolutely don't use camel case here. Camel case is really against the rules when we're talking about package names. So it needs to be all lowercase. All cool? So all lowercase, edu.ranken.paul_Smith is what I have there. Okay, that's the name of the package. Oftentimes to the end of that, I will add my the name of the project. I'm not going to do that this time because that would cause some more problems with the next project that you create. So I'm just going to leave it at this. Okay. The save location is important to change. Okay. So save location defaults to Android Studio projects. Okay. That's going to start out maybe not where we want it to be, right? We'd like this to be in version control. Okay. I think what I'm going to go ahead and do, since I haven't had you pull down the repo yet, I'm going to go ahead and leave it in Android Studio Projects for the second, right? I'm going to leave it in Android Studio Projects. And then we'll come back in the next project, we'll change it to our repository. So, Hello World is in Android Studio Projects. The language, I want to make sure I pick Java as my language of choice. The minimum SDK, you'll see there's a drop down here. I'm going to click on Help Me Choose. That's going to bring this up, and it's going to give us some idea of what different distributions are in usage. Okay. Google said that this is the most, they don't post this anymore on their website. They say, go see here. I don't think this has changed in a few years. I don't think what shows up in this dialog has changed in years. I don't know what that means as far as them not collecting data or whatnot, but I don't think it's necessarily advanced much further. What I would say for our purposes, I think let's go ahead and jump all the way up to 24. We're going to use 24 as our minimum this semester. So you're going to pick 24 from here. Make sure pick 24 is picked from there.
How did you get yours to have that color?
Huh?
You had something.
I hit Help Me Choose.
Oh, Help Me Choose.
If you go to Help Me Choose, you get this big panel out of here. So I'm going to go up to API 24 as my baseline. So that means that this app will not work on any devices that are older than 7.0. That means this app won't run on any of those old devices.
Yeah. Now, what's the purpose of going so far? Like,
yeah.
Why are they developing new operating systems if
right.
nobody's going to be developing for them?
So we are developing for 24 up to 12. Mm-hmm. We're developing for the whole range. We're not just developing for 24. We're developing for 7 through 12. 7 through 12. Android 7 through Android 12. All of those versions we're building the app for. Does that make sense? So given that we're building Zap 1, 2, 3, 4, 5, 6, 7, 8 different versions of Android. Do you see that? That's already a lot. That's already a pretty great range. But yes, it's a question, right? This has been, for the longest times when I started teaching this, I think that we were targeting Android 4.4 stuff or older. I think that we were around that range when we were targeting 20. 2019 when I first started teaching this a few years ago. So, yeah, there's definitely a question of like, well, how do you utilize the features that are in the newest devices? Well, basically you have to use some if statements and say, well, only do this if it's supported. So anyway, 7.0 is our minimum. This box that says use legacy Android support libraries, under no circumstances should you ever check that. If you check that box, delete your project, start over. That is for the older support libraries, which we really try to stay away from now. They've been replaced by something called Jetpack, which is what we'll be using here. Okay, so make sure you're not checking that box.
I get a warning on my save location. Says project location should not contain white space, as this can cause problems with the indicate tools. Should I ignore that warning? Because I've never had problems with white space before on this.
So a lot of tools, what they're saying is there are a lot of tools out there that do have problem with white space, and in general, you should never have white space in your house. Okay, not saying it necessarily will cause you a problem, but it might. Okay. In fact, one of the things that I would recommend when we're choosing where we put our projects, we want to really keep that path short. There is an upper limit in Windows to how long that path can be for a number of tools. Okay. So I try to keep mine as close as I can, my projects as close as I can to either the C drive or the D drive. That both avoids having a very long path, and it also avoids having spaces in it. If you're putting it on your desktop, you're putting in documents, your program files, any of those places, they're going to have spaces in it. So that's part of why I do that on mostly like D projects or C projects. Okay. But don't worry about it for the minute. Go ahead and hit finish and create the project. Okay. It's going to take a minute. It's going to take a few minutes probably for it to build the project, especially since this is your first project. Okay. If you look on the bottom, you should see on the bottom of my window it says Gradle is syncing, and there's a progress bar over here. We do have to wait till both of those things finish for the project to be ready to go. Okay. So that may take a few minutes before it's prepared. Okay. I'm going to check with everybody to see where everybody is. Finished building. But I see some errors there. So what I would recommend doing is actually closing Memory Studio and changing it back up again. And then when you do, just reopen the project and touch it. It does take some time before it can do this. Go ahead and hit close, or you would say don't show this. If you want that to be done. Okay. So the progress was. Okay, good. And this. Okay. So, right. There's this. So for most of us, it's currently working right now to pull down grading. Hopefully, it shouldn't have to do this every time, but it will definitely have to do this the first time that you run a project. So. Once it pulls down, I can kind of show you where some things are. But as this is going, one thing you'll notice, like for instance, in the project pane, you'll notice the project pane is still loading and such. It's still working while this is going. Sometimes what you'll see is as the project loads up, it might show up as a Java project, or it might not recognize what language it is in yet. Until everything loads. So I really suggest that you make sure to wait till all of those progress bars are done before doing anything in the Android Studio. That can be a really big gotcha, and if you're starting to write code in the interim before it's fully loaded, you can actually break your project, just a heads up. It is possible to break your project if you start writing too soon, which might not be something you're used to with some of your other IDs that you use. Josh and Aaron, do you have this progress bar going, or are you going with creating the project? Okay. Ours might be slower because we're running off of the Wi-Fi. Okay. So I've got this pane about Arctic Fox. This is telling me about new stuff. I'm going to go ahead and hit the minimize button over there. It looks like it's gotten maybe far enough for me to start talking about the UI. None of the files have popped up yet. Oh, there they go. There they go. Okay. So let's see. Is there a way I can get this bigger? Okay, I need to go to settings and make a change on my side. And what I want it to do is I want to be able to zoom in on the screen. Because I remember there's a switch I've got to change in order to scroll with the mouse wheel, or zoom with the mouse wheel. Oh, there it is. Change the font size with the mouse wheel. So it's under Editor General. Yeah, Editor General. There we go. So that at least let me scale that up a little bit. I think usually I find that I've got to do a little bit more because the UI itself is pretty small. So appearance. Did that change it? Okay, I'm going to go ahead and close this and reopen it to see if that applies the font size change. No, it did not. Well, that's interesting. So I'm not sure. Check something real quick here. Okay, enter Studio, menu bar, view, and they're going to appearance. No, goodness, whatever.